Hello students, welcome back to one more session of the bridge course. In today's session, we'll be learning one more important basics which is very essential in the various topics of physics that can be even competitive exam as well. And these basics you are already familiar with. So what exactly that basics? Okay, so here we have the basic mathematical formula. Now all these basic mathematical formulas you have studied in your lower classes, and these are very, very important, and you have to be very thorough with these basics, and that's what I'm going to explain. So I'm going to start with the first structure, so you can very easily identify. Yes, it is circle. So what are the various formulas associated with the circle, and then how these formulas we can use it in physics. So that's what I'm going to explain today. So therefore please listen and then do remember these formulas without any mistakes. Okay? Right. So first, what is circumference? Now when we say circumference, circumference is basically the total length of the circle. Total length of the circle is called circumference. So what is the formula for circumference? Okay, I'm going to write here. So it is C is the symbol used for that, and that C is equal to 2 pi r is the circumference. Clear? What next? Area of the circle. For area we use the symbol A. So do you know what is the formula for area? So area is equal to pi r square is the formula for area. So circumference is 2 pi r and the area is pi r square. What is the value of pi? Definitely you have to remember this value. Pi is basically it's a 22 by 7. But here when you divide this you will get 3.142 is the value of pi. So remember the value of pi is 3.142. Okay. Now based on these formulas, let's solve this particular question, which is related to physics. So check the statement here. An electron completes n revolutions in t second. First one, what is the total distance traveled? An electron, it's a elementary particle that revolves around the nucleus in circular orbit, correct? So this is how an electron revolves in the circular orbit. Tell me, when it completes one revolution, what is the distance traveled? So for one revolution, distance traveled, we know it, length of one circle. It is 2 pi r. But what is the question? Question is total distance traveled when it completes n circular motion. N is a number. For one circular motion, 2 pi r. For two circular motion, 2 into 2 pi r. Correct? 2 into pi r. For n circular motion, it is n into 2 pi r. So therefore, the distance travel, which I'll write as, is equal to n into 2 pi r. So this is the first answer to the first option. Okay? S is equal to n into 2 pi r. Okay. What is the next? Frequency of revolution. Now what do you mean by frequency of revolution? Frequency of revolution means number of revolutions completed in 1 second. Let me explain that. Frequency is always the ratio of number of revolutions, number of revolutions divided by the time taken. This is how we calculate. Number of revolutions completed in 1 second per second, is called frequency of revolution. So symbol for frequency of revolution I will use F. What is the number of revolutions given? It is n. So n. Divided by what is the time taken? It is a t. So divide by t. So this is the formula for frequency of revolutions. Understood? So this is the distance traveled. answer to the first option, and this is the frequency of revolution. Okay, how about the third one? Time taken to complete one revolution. Time taken to complete one revolution. Tell me, how many revolutions are there? N. And what is the time taken for it? T second. So let me write like this. For n revolution, it takes T second. For one revolution, S2, correct? That S2, I'm going to write it as capital T, okay? How much is this? How do you simplify this kind of mathematics? Cross multiply, correct? N into T, N into T is equal to small t, correct? So what is the capital T? So capital T is equal to, let me write here, capital T is equal to T by N, T by N. So that is the time taken to complete one revolution. And you know what? Time taken to complete one revolution is called as time period of revolution. It's called time period of revolution. Number of revolutions completed in 1 second is called frequency of revolution. You look at the formula for F. F is N by T. Look at the formula for capital T. It is T by N. Here it is N by T. There it is T by N. So therefore, we can conclude that F is equal to 1 by T. That is, frequency of revolution and time period of revolutions are inverse to each other. F is equal to 1 by T or T is equal to 1 by F. So basically, you can see we have made use of the mathematical formula in physics in understanding the motion of the electron. So this is how the different formulas are used in physics, and that's what I'm going to explain in the rest of the classes. Are you clear? Okay. So let's go for the next structure and next question. Okay. So we have one more question here. Let's see how to attempt this question. So let us solve one more question. Ratio of number of turns of two circular coils A and B made up of same length is 1:2. Ratio of radii of A and B is. So there are two coils A and B. Let N1 be the number of turns in the first coil, and let N2 be the number of turns in the second coil. That ratio is given. What is the ratio of N1 by N2? N1 by N2 is 1 by 2 or 1:2. It's a given, 1:2. So we have to find the ratio of the radii of A and B is. So let me demonstrate that as how we can make use of the same length. So I'm going to use a wire here. See, wire of certain length, this is the wire, okay? And I'm going to bend it to form a circular coil of one turn. See, just one turn with some length. Now I will use the same length to bend the coil so that I will form two turns. Can you see that? I have formed two turns. So that means when number of turns increases, you can see the radius of the coil decreases, it changes, correct? And that is what we need to calculate, the ratio of the radii of A and B is. So we need to calculate the ratio of the radius. Let R1 be the radius of the first coil, let R2 be the radius of the second coil. If R1 is the radius, what is the length of, it's a circular coil, what is the length of one turn of the coil? Length of one turn is a 2 pi R1. Correct? It's a 2 pi R1. That is for one turn. For n turns, it's N1 into 2 pi R1. N1 into 2 pi R1. And if you multiply the number of turns with the circumference, you will get the length of the coil, because it is the same length, with which we have wound the coil. Since the length is same, this is also equal to, what is the length of one turn of the second coil? It's a 2 pi R2. Correct? Length of the second coil of one turn. But how many turns are there? N2 turns are there. N2. So it's a N2 into 2 pi R2. Why have we equated with L? Because both the coils are made up of same length. Now what do we want? We want ratio of the radii. So here it is. When you equate, this 2 pi will get cancelled. Ratio of the radii is R1 by R2. R1 by R2. What is R1 by R2? R1 by R2 is N2 by N1. N2 by N1. But what is N2 by N1 from here? N2 by N1 is a 2 by 1. 2 by 1. So therefore the answer is choice 3. Understood the method of finding, and 2 pi R1 is for one turn. This is for n turns. Total is N1 into 2 pi R1. For the second coil, 2 pi R2 is for one turn multiplied by the number. And why it is equated? Because both the coils are made up of same length. Are you clear? So that's why a ratio of the radius is given by 2:1. So let's solve one more question. So these are all application, very simple application in physics where we use various mathematical formulas. Okay, right. So let's see the statement. The statement is, a man moves along diameter of a circular path. So this is the circular path. This is a circle. So he moves along the diameter like this. Okay, along the circular path of radius r. So radius is given r. So what is the diameter? Diameter is 2r. Radius is r. Diameter is 2r. Okay, and returns back along the circumference. So he goes like this and then returns back along the circumference like this. Okay, what is the total distance traveled? So total distance traveled, first this is the path. How much is that? It's a 2r. Then this is the path. Remember, this is not full circle, this is semicircle, half circle. For one full circle, how much? 2 pi r. For semicircle, pi r. Pi r. Okay, so r is common, you will get 2 plus pi into r. 2 plus, what is the value of pi? 3.142 into r. Just add them now. So you will get 5.142 r is the distance traveled. So that can mean meter, centimeter, kilometer. Unit is not given here. So I am going to write only the values. So hope you have understood. One more application to find the distance traveled by body. Okay, right. So the next, another structure. Identify this. Very easy. I am asking all easy question. So it's a definitely a rectangle. So what is the area of the rectangle? So area of the rectangle is, L is the length of it. So this is length, L. B is the breadth of it, L into B. So the area is length into breadth. Correct? Very simple. Diagonal. So I want this. This is the diagonal. What is the value of that diagonal? The value of the diagonal, I can find it. This is L, this is B, and this is a right angle triangle. Correct? No? So how do you find the diagonal? Using the Pythagoras theorem, which is diagonal. Okay, I will write a D. It's a root of L square plus B square is the diagonal of the rectangle. Are you clear? Okay. Let's see one more structure, one more formula. Okay, that is a square. Right? What is the area of the square? For a square, I am going to consider its a side to be equal to A. Side equal to A. So what is its area? So area is it's A square. What is the diagonal? What is the value of the diagonal? So diagonal, again you can make use of the Pythagoras theorem, which is equal to root of A square plus A square. Now what is the root of A square plus A square? It is root of 2A square. But what is the root of a square? Root of a square is a. So therefore, do remember that diagonal is always root 2 times a. Diagonal is always root 2 times a, where a is the side of the square. Clear? Okay. So let's see another structure, another set of equations. Fine. What is this? We are done with the circle, correct? No. So this has to be a sphere. Now, what is the area of the sphere? The area of the sphere is 4 pi r square, where r is the radius of the sphere. 4 pi r square. Pi r square is the radius of the circle, but 4 pi r square is the radius of sphere. What is the volume of the sphere? Volume V is equal to 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of the sphere. Now this sphere, if I cut into exactly half, then we call it as hemisphere. So hemisphere has an area half of the area of the sphere. So half of this. Half means I have to divide by 2. When I divide by 2, what I am going to get? 4 by 2, I will get 2. So therefore it's a 2 pi r square. Half of it, okay. Similarly, volume. What is volume? Half of this. So divide by 2. When I divide by 2, 4 by 2, I will get 2. So therefore volume is 2 by 3 pi r cube. Understood? So half of the area of the sphere is equal to 2 pi r square, which is the area of the hemisphere. Half of the volume of the sphere is equal to volume of the hemisphere, which is 2 by 3 pi r cube. Okay, so hope you are following whatever that I am explaining, and these formulas are important. You have to be very thorough with these formulas. If you have forgotten, time to revise them. Okay, right. Let's go for the next. So there is a problem. Let's try this numerical. What is that? How many moons exactly fit inside the earth if the earth diameter is 3 times the diameter of the moon? Okay, let me first tell you what exactly this question is all about. So we have, let me draw that. So here there is an earth. Okay. So this earth has some radius. I will write RE. RE is the radius of the earth. And we have a moon. And this is the moon. And I'm going to write RM is the radius of the moon. Okay. Now it's given that the diameter of the earth is 3.7 times the diameter of the moon. It's given. Diameter of the earth is more. 3.7 times the diameter of the moon. Now I'll write in terms of the radius. What do you mean by diameter? Diameter is always twice the radius. 3.7. Diameter is twice the radius of the moon. Correct? No, diameter is always twice the radius. Now this 2 will get cancelled. Therefore, radius of the earth is also equal to 3.7 times the radius of the earth. So this point you have to remember. If the diameter is 3.7 times the diameter of the moon, radius is also of the same factor. If the diameter is 10 times the diameter of an object, then its radius is also by same factor, 10 times the radius of the other object. Okay, there is no change in the factor. Okay, keep that in mind. Because on both the side, that number will get cancelled. Okay, so now we are ready with this. The question that is asked is, now this moon I will place, just imagine. Okay, imagine. I'm going to place, we have to assume that, the earth is hollow. These are all hypothetical. So I'm going to place one moon here inside, because it's a smaller. Can we place some more moon inside like this? Yes. So question is, how many such moon that will fit inside our earth? If you imagine that, if at all, if it is possible to fit in, then how many such moon? Only for calculation purpose. So when you fit in, let n be the number of moons that we can place inside. Imagine how many n such moons. And now after placing all those number of moons, now volume of Earth is equal to n times volume of the moon. Correct, no? The volume of that one Earth, volume of that one Earth is equal to n, because there are n such moons are there, n times the volume of the moon. Correct? Okay. So what is the volume? Assuming Earth to be almost sphere, even though it's not, let's assume that it's almost sphere. Then what is the volume of the Earth? It's a 4 by 3 pi r cube e, pi r cube e. Now that's equal to n times what is the volume of the moon? 4 by 3 pi r m cube. See, we are using the volume of the sphere formula related to the Earth. So this is how the maths formulas comes handy in attempting some questions like this. Are you clear? Okay. So 4, 3 pi will get cancelled. Do you agree? So now what is left? N. I have to find that n. So what is n is equal to? N is equal to Re by Rm, both cube, right? Cube and cube. Which I can write like this, Re by Rm, the whole cube, because power is the same. But what is Re by Rm? Re by Rm is given here, Re by Rm. So this should be Rm, sorry. Okay. What is Re by Rm? Re by Rm is equal to 3.7. So therefore this is equal to 3.7 cube. And if you make use of the calculator, 3.7 cube, you'll get an answer nearly, okay. How to find cube? Calculator is it. Multiply 3.7, 3 times, you'll get about 50.7, which I'm going to round it. So 51, that means almost 51 moons can be placed, inside the Earth. So Earth is such a large sphere. So you get an idea how big the Earth is, so that 51 moons can be placed inside our Earth. Okay. So this is again an hypothetical, but definitely an example where we can make use of, the volume formula. Okay. Are you clear with this? Okay. Let's go for one more structure. So we have few more such structures. They're all useful equations. So let's go for the next.